starting with steel structure. The first thing, what are steel structures? So we are constructing something with the structural steel as the main load-taking material. Okay. In RCC, we have both. We have concrete and we have reinforcing material as load-taking uh, material, load-taking element. So it is a composite element. We have RCC. In RCC, we have concrete and reinforcing. It is a composite material that is taking the load. In steel structure, we have some structural steel elements that are taking the load. So these structural steel elements, we have different names according to their shape. I section, T section, C section, etc. Steel plate, etc. And we already know that the RCC sections are what? We can make them at the field, at the site, according to our requirement, according to the sizes and dimensions, we will prepare them at the site. But the steel structures, they come from the plant. They come in standard dimension. Um, so that is one difference. And then steel composite structures, steel and concrete composite structures are used for high-rise building. If we go for high-rise building, then obviously the effect of earthquakes, wind loads, and other loads also more. So we need greater strength. In those cases, we may go for a part will be of RCC, or we may provide strength to the structure by providing bracing. Okay, you might have seen this kind. If there is a building like this, if there is a building like this, then these are the columns in the building. For example, you might have seen, okay, this type of steel elements. Okay, so this is called bracing. Those steel elements which are acting as bracing, they are doing what? They are providing strength and stability to the structure. So these kind of things are also there. But for the time being, what we will study RCC separately and steel separately, and later we will combine those things and see what happens. Now, what are some common steel structures? So roof truss in factories, some cinema halls may be also steel structures. Why? Because the steel is stronger. The steel allows us to have a large area. In RCC, there will be a limit. Okay, we cannot go for a very large span of beam. Okay, the distance between column to another column cannot be very large. But in places like cinema hall or an auditorium, this thing there, what we require, we need large open area. In those cases, if we use steel, which is stronger, it can give us large distance between one column to another column. So that serves our purpose of filling in more people in that area. So this type of things may happen. Then crane girders, plate girders, bridges, obviously, transmission towers that we see all the time are of steel structures, right? So some of these steel structures, this is an industrial building, okay? An industrial shed is being constructed. So here we have this footing. Over that footing, we have steel element, we have truss system for the roof. Everything is of steel. Then this is another shed. This is an arch steel building. So here we have steel, which is acting as an arch system, okay? Then this is a framed steel building. Okay, it is just like it is coming up like beam, column, and slab that we have in RCC, but this is made of steel. This is a truss system, okay, made of steel element. This is a bridge, which is made of steel element. Another big bridge, very iconic bridge. So this is also steel element, and then supported by the suspensors. So steel is used in lot of constructions, in lot of high-rise and high-demanding structures where we need greater strength. we may opt for steel, even though steel is costlier. Another iconic, some iconic buildings, right? These transmission towers, we see them all the time. They are also of steel. Why? Because these transmission towers are always under tension. These cables are always applying some tensile forces on the towers. Now we already know that concrete is not good for tension. So we have to go for steel, which is good in tension. That can take the tension, right? So that is the reason. And some related things are also there, like how to be how the foundation is to be designed for this, because in this type of structure there will always be an uplifting force along with the tensile force. Those things we will learn in geotechnical engineering. Then coming to advantages and disadvantages of steel structure. So first thing, the steel has high compressive and tensile strength per unit weight, hence low construction weight, and saves space. What it means that steel is stronger in compression and in tension. In both tension and stress, the steel is stronger. That means it can take more load. And if we go for a comparison, because it is stronger, to, to handle same amount of load, if we need this much concrete to support, say, for example, 100 kilonewton of load, okay, if we need this much amount of concrete, then we will need this much amount of steel, okay, to handle the same load. Why? Because the steel is stronger. So what it does, it is saving space. So that is very important. It is saving space. Okay. If we need this type of large column at a short distance, okay, in case of RCC, the same thing if we construct with steel, the column sizes will be smaller. The distances between column and another column will also be smaller. That means we have more space in between the columns where we can accommodate our required furnitures or people or whatever it was. So this will be very important in case of places of large gathering, like an auditorium, like in cinema hall. These things where we need large spaces in between, so we may go for steel structure. Then aesthetic view can be one option. Good quality and durability can be another option. Durability, we will need to do some treatment for proper durability, but the quality, if the quality factor, why? Because the steel elements are prepared in plants in standard conditions, so they are always of good quality. But RCC, what do? We prepare them in the site. We mix the ingredients in the site and then we prepare the reinforced concrete or concrete. So what may happen due to ignorance of some person, due to some mistake made by some of the persons working there can be low quality RCC. For example, one person unknowingly mixed greater amount of water in our mixer of concrete. So what will happen? The strength of the concrete will decrease. For example, I'm saying, but the steel, they are prepared in the plants, standard conditions. So they are of good quality, superior quality. So there is less chance that it will be faulty. And that is the reason why we consider factor of safety as 1.5 in RCC and 1.15 in reinforcements. Why? Because these reinforcements are prepared in the plants in standard conditions. The chance or the probability of making an error or mistake is very less in case of steel. Then, very high speed construction. Okay, we already know that RCC, if we are going to construct it, we have to give it some time. We have to wait for it to set, strengthen. We have to do curing. We have to wait for it to gain strength. But the steel, the elements of steel come from the plants directly. What we will do in the field, we will fix them. We will do bolting or riveting or welding. There are types of connections. We will do that type of connections and we will construct our structure of steel. So it is very high speed construction. So for example, if we are going to construct something in the highway, we should prefer something which will be done very quickly, right? So we may go for steel construction because we do not want to block the highway for a longer duration of time. So we will go for steel construction. Then reusability. Now, when we are dismantling the steel structure, if we can open the joints, if we break it at the joints, then the elements of the steel can be again used for some other purpose, maybe if not in the structure, if not in a building structure or some other bridge structure, it can be used in some other low value work. Okay, we do not have to throw it away. But in RCC, it is not that case. We are trying to find opportunities, we're trying to find methods with which we will be using the aggregates again, but it's not that good yet. People are doing research how to use those scrap from the RCC structure, how to use the already used aggregate, how to reuse it. So people are doing research on those factors, but we have not achieved a great deal yet. But the steel, obviously, we know can be reused. And this one point, better solution to cover large span and tall structures. So because it is stronger, it can be used for large spans and for taller structures. Then if we come to the disadvantages, high cost is one disadvantage. Corrosion may occur if we do not treat it properly. This condition is related to this condition. If we have treated it properly with corrosion resistant substances, then the durability will be higher. If not, there will be corrosion and durability will be lower. And low fire resistance. Okay, the RCC will have higher fire resistance because of this concrete. Okay, now this fire resistance does not mean it will catch fire. Okay, it means that it will deteriorate in fire, okay, in temperature. So RCC is, the steel is covered with the concrete. The concrete layer provides the resistance to the fire, but in steel the resistance to the fire will be less than the concrete. So that is another disadvantage. Okay, then how steel is made. So there will be iron extracted from iron ores. We know iron ore. So these are the elements that we collect from the sites. Okay, there will be some ore sites where we get these elements from the below the surface of the earth. We know that. Okay, hematite, limestone, magnetite. These things we will collect. Then we'll refine them. Then there are some procedures. We will go through them again later. So oxygen will be passed. We will remove the carbon and unnecessary elements present there. Okay, we'll add manganese, we'll add chromium, nickel, phosphorus, etc. We will add. There is a procedure. We will go through it properly later, and then finally we will get steel. Okay. So one thing we should know that adding carbon in the manufacturing process, we can vary the amount of carbon added. Obviously, the carbon added increases the tensile strength and hardness, but lowers the ductility and toughness. So this point is important. We should remember, if we add carbon, the tensile strength and hardness will improve, but ductility will decrease. Ductility was the ability to elongate. Toughness was ability to absorb energy. So those things will decrease, but overall strength will increase. Now, steel sections. The standard steel sections are available this way. So this can be a T bar because it looks like a T. This can be an L because it looks like an L. This is HSS, which means hollow section. Then this means this and these are almost same. They are I-beam. This is wide flange. This is smaller flange. And this is a channel or C section because it looks like a C. Okay, this is hollow section. This is C section. Thus, the way they look, we have named them. Then you should be knowing this, I guess. So this both are I-beam. This is web, and this is called a flange. According to their property, their strength, their moment of inertia, those properties will vary. And according to that, their strength, their usability in a structure will vary. So we will get there. Okay. So that much for today.